You're listening to the N2K Space Network.
Quick question. Do your end users always, and I mean always without exception, work on company-owned devices and IT-approved apps? I didn't think so. So my next question is, how do you keep your company's data safe when it's sitting on all those unmanaged apps and devices? 1Password has an answer to this question: Extended Access Management. 1Password Extended Access Management helps you secure every sign-in for every app on every device because it solves the problems traditional IAM and MDM can't touch. And it's now available to companies with Okta and Microsoft Entra and in beta for Google Workspace customers. Check it out at 1password.com/cyberwire. That's 1password.com/cyberwire.
I'm Maria Varmazes, host of the T-Minus Space Daily Podcast, and you're listening to T-Minus Overview.
T-minus 20 seconds to LOS.
In this program, we'll feature some of the conversations from our daily podcast with the people who are forging the path in the new space era, from industry leaders, technology experts and pioneers, to educators, policymakers, researchers, and more. So when we think about engineering in the space industry, most of us are guilty of thinking about aerospace engineering, mechanical engineering, and even chemical engineering. But what about structural engineering? Who's building the structures that support the growing space economy, both here on Earth and in space? Well, we're about to speak to two structural engineers to find out more. Let's start on terra firma, shall we? Jennifer Spears is the Vice President of Engineering at Merrick & Company. She has a really amazing role as the engineer of record on the Space Launch System's test stands, and I was interested in hearing more about how she got into her role.
I am with Merrick & Company. I am a senior structural engineer, and I am also the Vice President of Engineering for the entire company. Some of my, claim to fame, so to speak, is I was the structural engineer of record for NASA's SLS Space Launch System liquid hydrogen tank structural test stand at Marshall Space Flight Center in Huntsville, Alabama. So that was a great key project for our company. For me personally, it's kind of one of those once-in-a-lifetime opportunities. I mean, how often do test stands be built? We built on the site of an Apollo test stand, so, gives you an idea of how often they're being built.
The legacy, yeah.
I know. And then I also oversaw the construction of that test stand, plus our company designed the liquid oxygen test stand for SLS, also at Marshall Space Flight Center. And so the construction was at the same time, so I oversaw the construction for both. And I'm also the structural engineer of record for some new Artemis platforms that are being constructed right now to go into the vehicle assembly building at Kennedy Space Center in Florida.
Oh, that's so cool. Given what you do and what you build and what you work on, can you tell me a bit about your education, your career journey, how you got to where you are today?
Sure. Really, it started pretty early. So when I was I think, sixth grade, my math class had a unit about tracking satellites. And I thought that was the coolest unit. I'd always had an interest in space, but that somehow clicked something in my brain that I was like, oh, maybe this is something I want to do for the rest of my life, something associated with space and NASA and everything. And so that was in my thought process. And then in eighth grade, we had a careers class. And you had to do research on a couple of top careers. And so, of course, I was like, oh, aerospace engineering, that's really piqued my interest. let me look into this. And so I did the research for the class, and I was reading about how the shuttle platform may be going away, and not to knock planes and those that work on them, but that didn't interest me. And I really liked the space aspect of NASA, and so I didn't want to go down the path of getting, an education for a career that maybe by the time I get that education, I'm not going to have anything to do that's in the field of what I love. And so freshman year of high school, I took an intro to engineering class at one of the universities. It was University of Missouri Rolla. We lived in Kansas at the time, and it was a week-long class during the summer where you got to go and explore all sorts of different engineering disciplines. So I looked at structural engineering because I liked Legos and I liked Lincoln Logs and I liked building things. And I was like, well, I've already turned down, I've already ruled out aerospace engineering. So let's see what else. And I really loved the structural engineering. And so freshman year of high school, I decided I was going to be a structural engineer. And so I continued down that path. I went to school at University of Illinois at Champaign-Urbana. At the time, they were one of the top one or two alternated every year of the number one civil engineering schools in the country.
I was going to say it's a great engineering school. I know it well. Yeah, yep.
And so I did my undergrad there, and I did my grad there, and then decided to move to Atlanta after grad school. And I've been here ever since. And I've worked at a couple of different companies, and then had some friends that worked at Merrick. Reached out to my friends, and I was like, if you got an opening, let me know. And so they had an opening, and I've been here ever since, and hoping to finish out my career here. So it's a great company and love it. And I love the work we do. It's been a nice bonus then. So when I started, we do a lot of government work, Department of Defense and various, things at installations, whatever. And we got the test stand project. And so I started working on that. And it was like my childhood dream coming true.
I was going to say, yeah.
It was the NASA coming to fruition, but also the structural engineering, which I do love. I still love Legos and building things and getting to do it in real life with steel and concrete and everything. And I love the work that we're doing with aerospace and it's really exciting getting to be a part of history. It's a brand new rocket, the Space Launch System that I've been working on for the last 12 years. It's exciting to say that I've had a part of history and helping that to come to fruition. And I'm excited getting to work with commercial entities and propel that into more mainstay and see how that grows and help that progress. And it's really exciting to get to do both aspects of what I've loved since I was a kid.
I love that. I love that for you. Oh my gosh. I was going to say, getting to be a structural engineer, building those cool things on its own is amazing. And then eventually your career leading you to something, building things for space programs is like, what the cherry on top of.
Yeah.
It's just so good. Oh my gosh. That is like the perfect example of something we talk about a lot on the show about, your career taking you to cool places. And if you're interested in space, it doesn't mean you have to be like an aerospace engineer. You really you can take other paths. All right, so you have worked on, in the space realm, something very, very, very cool things. When you think on that, and how much work that was, how much effort that's been, what it has helped build to. Aside from being, I'm sure, extremely proud of the work that you've done. What comes to mind? What bubbles up when you think of all that, just at the macro level?
Honestly, at the macro level was being there for Artemis 1's launch. So I started working on NASA when my oldest child was 1 year old. So I've got 3 kids. All they know really is mommy does stuff for NASA, that I'm a structural engineer and I do stuff for NASA. And I was going to be at that launch. So we drove down for every single launch attempt. We were there when it launched. November of 22, and at like 1 a.m, and my kids were there with me. My husband was there. They were there. My son turned to me. He's like, "Congratulations, mommy." I was like, "Oh, that's fantastic." So it does. It all boils down to, just like I said, being a part of history and being a part of it, and being able to say that I helped us get there. And the test stand was exciting, because, like I said, they hadn't built another test stand in, I think, like 40 years or something. So it really is like a once in a career opportunity. And so we designed it, and they gave us the parameters when we were first starting to look at it. We're designing for something that's also being designed. I mean, at the time, the rocket was still in design. So we ended up designing the test stand actually like 6 different times by the time all was constructed, because the vehicle itself was being constructed. So the loading requirements changed and whatever. And that's okay. That's how it works. That's part of, there's never a dull moment when you're in the aerospace industry, because it's not your day-to-day operations. There's always something different. And so it's really exciting, because it's got the ability to be reconfigured for different articles. In fact, they recently reconfigured it so they tested the hydrogen tank. Everything went fantastically. They tested it to failure, and the test stand, held up beautifully and
gorgeous. Yep.
which is what I, of course,
which is what
mostly
you want.
cared about. Yeah.
Yeah, you want that. Yeah.
Right. And
yeah.
so, but it's nice because it's got this movable load deck, so that they can like raise and lower it like 170 feet. And so they just reconfigured it to test a new component, which is exciting, that they can continue to use this, for all who knows what the different rocket configurations are going to be going forward. And, that Artemis isn't going to be the last. NASA's not the only space entity anymore. And, but they've got this, that it can be used for a very long time, and for different rockets, different configurations. So
you're still working on a lot of incredible things now. I mean, it's got to be exciting. What are you looking forward to? Like, what do you feel like that's coming next that you just can't wait to share with the world? I mean, okay, maybe you can't tell me.
Yeah, I'm not quite sure how much I can share about my next upcoming project, other than to say that there's future configurations of Artemis that are taller, bigger, have additional components. And I'm really excited, because we're getting ready to start design for another structure that's going to help them with the assembly and processing of some of those future components. So we're still working on new versions of Artemis, and that, it's still evolving, it's still growing, it's still changing. The work that we're doing to help, like I said, some of the commercial entities as well, because I think that the more people we have in the space game, the more innovation we're going to get, the faster things are going to grow and progress and get perfected, so to speak. That will, I just think it's great to have more people coming to get to the table with more ideas, and whatever we can do to help those is exciting.
Humanity has long imagined what living in space might look like. We've seen it in sci-fi movies, series, and graphic novels, but science fiction will soon become science reality, as space companies today are developing the next generation of places in space where humans will work and live, in forms that might surprise you. So what do future human habitats in space look like? Our next guest is Sean Buckley, Vice President of Destinations at Sierra Space. Now, Sierra Space is building large, integrated, flexible environment habitats known as LIFE. Their vision is to reshape how humans live and work in space.
Sierra Space has 3 pillars. Those 3 pillars are, you have transportation, you have destinations, and then you have applications. So basically applications, if you think about it, builds everything that's inside our space systems, inside the Dream Chaser, inside the Habitat, and they really focus on our OMS, our satellite division. They do a fantastic job. You probably heard a couple of the recent awards that we've gotten. And then you have transportation, obviously Dream Chaser plane, which is absolutely fantastic, right? Revolutionized, land on runways. It's just, you look at it and you think shuttle, right? And then you just think advanced technologies of what the shuttle was doing, and its capabilities are phenomenal. And then you have destinations, which I now get a chance to lead, which is everything in space, right? And wherever you're going to live, whether it's metallic habitats or it's soft goods habitats, whether it's going to be in LEO or lunar surface.
I just have to say on the macro level, the fact that it's destinations with an S, as you mentioned, there's more than one that Sierra is working on its own. I'm just like, what a great time to be alive that is the discussion right now.
I mean, to be part of Orbital Reef, right? I mean, that's an incredible program to do. And to be building and designing our space station, right, which is absolutely amazing. And then to be looking at, things in cislunar, right? So at Gateway. So NASA Gateway is doing on there, looking at how can we service Gateway? What can we do for Gateway? And how can we work with NASA on that? And then, on the lunar surface, you're thinking about how do you occupy the lunar surface? How do you do something on that surface, which is obviously one of the most challenging environments that you can have. We believe our inflatable technologies, along with what we're designing as far as the support systems, are really a viable product. You launch small, it's low in mass, low in weight, and then you can land and you inflate it and you have all this volume. And anytime you're going to discover a new place in the world, talk about the settlers, right? Going across the United States, they brought a wagon with them. How do you bring a wagon with you to the moon?
Conestoga wagon in space. I love
in
that.
Space, right? And then how do you have an establishment settlement so that you have a place to stop as a waypoint? If you're traveling across the United States, you had these little cabins or these little stop places, which were your convenience store, your grocery store, wherever you would stop, and you'd pick up your supplies for the next journey. When we go to the lunar surface and you land on the lunar surface with a lander, you need a place that you can stay at, which should be an inflatable. Hello, it's the best technology in the world. And then, but when you embark out of there, you want to be able to go to another waypoint, which you're going to get power, which you're going to get supplies, which you're going to get whatever you need. This is really what we're looking at, to build that ecosystem, which is on the lunar surface. And all the testing we've been doing at subscale and all the testing we're doing at full scale is building up that complete product line to show how we can apply it to cislunar and lunar and the lunar surface and deep space, obviously.
This is so stinking cool what you're doing. And also, I mean, not everybody gets to say they're working on more than one of these at the same time, but also just the designs are so cool. I mean, I know nothing about architecture. I'm just a noob on any of that stuff. And I just look at it, I'm like, wow, that's a viable thing that we can do. I never thought that such a thing could be possible.
It's pretty trippy. Like you look at it and you're like, well, wait a second.
Yeah.
You're taking soft goods and you're putting around some kind of shell and you're pressurizing it in space and we're going to live in it. Are you sure you know what you're doing? I mean, those ones, are you sure? Is it like my shirt? And I'm like, well,
but to me, it's like it opens up this realm of possibilities that like I had never considered was ever even possible. And it just makes me go like, what else haven't we ever thought of that we could actually do? Oh my gosh, like human beings are so amazing that
That's
we can
unbelievable.
Think of stuff like this.
So when we form as a team, you want to look at what's impossible and then go figure it out. I mean, and find the most simplest, basic way to approach something. Part of what we design with soft goods is based off of technology that's been around for 2,000 years. So if this technology has been around for 2,000 years, how can you use it in space? And it's basket, right? And how do they do baskets and move things around for years? It's so basic and so simple, but you apply it to the hardest environment in the world, and we bring on really smart people. Our M&P, material and process individuals, they have the amazing job to select the materials that we're going to use and go test the materials and say, hey, team, we have these materials you can use. And they build it into an architecture. And then when you see it come together, you're like, wow, this is awesome.
So Sean, for the edification of our listeners who may not know what you mean by soft goods, because I have a generalized idea, but I could actually be wrong, what I'm assuming. So could you define it for me?
Sure. When we say soft goods, when it relates to space habitation, it's really advanced materials that we're applying to survive in space. Sierra Space, we talk about, I go from what's called the intermold line, so IML, to the outer mold line. So what inner mold line is whatever the astronauts or inhabitants are going to touch. We have what's called an atmospheric barrier. So when you see us inflate, it requires something that can allow that air not to penetrate. So it has to have a low penetration value. So that soft goods is that first liner that we're going to do. So when you pressurize with the atmosphere, if you're going to be like the International Space Station, 14.7 psi, you'll pressurize, and then it's going to force the soft goods to expand. When you see our burst testing, you're going to see something that looks like it's woven together. It's made out of Vectran. And Vectran is a chemically spun polyacrylate. So basically, this material is developed in its strands, and then we take it and have it weaved, and then it's put into a basket form. And then that basket form creates this incredible architecture we have really strength. We work with one of our partners, ILC Dover. We work together on the architecture, the design, and then the manufacturing, and we put it together. So we want to leverage their expertise in the soft goods world, and then obviously the individuals that we brought on board to enhance that expertise and to create this good synergy between the two companies. Then outside of that is a layer of MMOD. It's called micrometeor orbital debris shield. A lot of words.
Yep.
What
but
this
a lot
does,
of people are going to have that question. So
a lot
yes,
of people are
yes.
going to ask, right? So when you're in space and you have all that debris that's hitting it, what we do, depending upon where we've placed the space station, we run what's called orbital debris models. We work with NASA. They're called ORDM models. And it tells you where the debris is in space and how many times it's going to hit your habitat and what's going to hit it or whatever you have in space. And then we run what's called PNP, probability of no penetration. So this is going to tell you what's the probability of that hitting there, number of times over years based on mission duration. So we designed this multi-layer shock shield, which can stop any debris in space. So the outer layer hits the outer layer and it destroys it. So it fractures the piece. And then these other layers that are in there catch it. As it goes through it, it catches. And we put space between the layers because if you take basic momentum, you want to slow down the momentum as the first piece hits, and then you want to slow it down to the next, to the next, to the next. So we've designed this type of shield that we'll use. And then on the top outside of that, you got to stay nice and warm, right? Or you got to stay nice and cool. We have what's called a multi-layer insulation blanket. Basically, it's your thermal blanket. No magic here. It's standard MLI blankets, which has been created for years. But when you take and put all these layers together, the magic of this, or the secret sauce that we have, is how do those layers react to each other? How do you pack it around a core, like pack it nice and tight, launch it in a 5 meter, 7 meter, 9 meter fairing, and then when it goes in space, lack of a better term, you press a button, and then it's got to pressurize and expand. And when it pressurizes and expands, it gives you this increased volume. So as an example, when we launch the Life Habitat, it'll launch roughly 40 to 50 cubic meters in volume because it's packed. When we get it in space, it's 285 plus cubic meters. So you launch really small, you get large volume in space. And that large volume in space helps you sustain that 15-year mission because you can place your crew quarters in there, your exercising in there, your science and biopharma experiments, your microgravity work that you're going to do inside there, your manufacturing that's going to happen in there. Basically, it allows you to create the next industrial revolution. You can take the soft goods, you can take the core structure, you can take everything that's being designed as far as drugs or as far as advanced manufacturing, put it in space and get a different element. Things fuse together differently. And you're going to see a lot of this over the next decade on how Sierra Space leverages this technology that's terrestrially developed. We're going to place it in space, and we're going to develop the next cure for cancer. We're going to develop the next printed, tissue that's up there. We have teaming partners that we're working with, Redwire and other companies, and these companies have these advanced solutions. And what we're doing is integrating them into our ecosystem. And as they're integrated into the ecosystem, we partner it up, and then we put it up in space, and then we're able to get incredible synergies. So again, think about it. We have the application team, right, which is designed and develops all our systems internally. And of course, we have outside vendors and partners we work with. We have the Dream Chaser, which takes you and transports you up there. We have the destination where you go, and then you transport it back down. So a complete ecosystem that Sierra Space is driving. There's really no company that has what we have in this place. But that's the background on soft goods and basically overall what we're doing.
What has often struck me also about when I've seen the inflatable, like the models of them, the quality of life also for the crew. In addition to all the things you've mentioned, just like how much they're not in a metal tube in space anymore,
We have an amazing astronaut, Tom Moshburn, who's on our team, right? So he's at Sierra Space, and he is critically important as part of what we're doing. And his feedback has been so valuable to us. And he walks in there, I think he said a couple of times, he goes, you never to get an astronaut that'll complain, wow, that's too much space. Hey, you gave me way too much space. You know what I mean? This house is way too big. I don't think we should be up here. They want the room to stretch and to be able to do things and do other stuff. So Yeah, really appreciate it. I mean, I think the designs that we're doing, I mean, we're testing what we call Life 285. We're testing that in June. But at the first of next year, our goal is to test Life 500. So we're going to go from 285 cubic meters to 500 cubic meters. That's pretty much the biggest that I've ever seen, ever know of, and have ever been involved in testing a habitat. So this is a real challenge. The team's got a challenge ahead of them. But like I said, we got great partners that we're working with, and obviously the internal team. So,
Sean, I could probably talk to you for hours, honestly, because I'm like, I have so many questions. I feel like at the very least, I've taken a half an hour of your time, and I appreciate that. Is there anything that you wanted to mention before we close out? Because I probably should let you go.
I know. I was thinking, do I have anything else? I can imagine I'm getting pinged. I can see the other, hey, where are you? Are you coming to this meeting? Are you doing this? I'm like, hey, you're not important. Come on. I'm talking cool stuff right now.
I know you're a VP now. I got to let you go.
You guys can wait. Oh, no, they can wait. There's 24 hours in a day, and I'm willing to work 18 to 20 of those. So if it means I got to take 30 minutes on here, and again, I don't know if it's work, because when I sit working on things at night, I'm like, oh, this is so cool. I'm looking at this. Wow, I'm leading this. Oh, that's great. I'll tell you, I'll close this out. I had a funny story the other day. We were talking about something internally, and they were going through the meeting, figuring out who was going to have the authority on it. And I was sitting in the room going, man, I don't know who approves this, who does this. And I went, oh, that's me. I was kind of like, wait a second, I got to take a different view of this. Like, maybe I need to write down what's going on here. It was so funny. Wait a second, I did. I said, and I don't know if I was in the meeting and I said it, because I was like sitting here and I went, oh. You know what I mean? I caught myself, because I was like, wait a second. I was like, no, I got to change here. I should be more stoic. I should be like, that's an interesting concept. Let's see what we do next with this. Programmatically, I think our approach should be, it was very funny. What I could leave you with is, I think in life, we all have challenges that approach us, right? The road is never easy on how we have to travel. And I've had my ups and downs and failed businesses and things moving forward, and technologies have not worked. But I have always said that if you run into those areas where you see there's no light at the end of the tunnel, you have to find the light. You got to figure out a way to enjoy what you do, keep a smile on your face, and laugh a little bit and enjoy it. I mean, you got to be serious when it's time to be serious. And you have to make those hard decisions every single day. But if you can't, at the end of it, laugh a little bit and really enjoy your job, what are you doing? I mean, I can't be there if I'm not enjoying what I'm doing. And there are challenges. I just make sure that I try to laugh as many times during the day as I can, and smile as much as I can smile, and just really enjoy what you're doing, and eat lunch. I mean, that's one of those other things I really got to do. So that's really what I would leave you with. I think if everybody took on those challenges and took ownership for what they do, the world would be a different place. You have to own it. And I love owning the good, the bad, and the ugly, because that's just what we have to do. So, and again, privileged to be with Sierra Space. I mean, they're an incredible support system, and the vision that we have from the CEO down and from our investors is just amazing. It's the reason why I'm here. So, I mean, I love the job.
Thank you to our guests today, Jennifer Spears and Sean Buckley. If you're interested in hearing more about the space industry, join me every day for T- Space Daily. It's available on all major podcast platforms, and you can find out more at space.n2k.com. We'd love to know what you think of this show. You can email us at space@n2k.com. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. This episode was produced by Ellis Caruth. Our associate producer is Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Our executive editor is Brandon Karpf. Simone Petrella is our president, Peter Kilpie is our publisher, and I'm your host, Maria Varmazes. Thanks for listening. We'll see you next time.
Identity architects and engineers, simplify your identity management with Strata. Securely integrate non-standard apps with any IDP, apply modern MFA, and ensure seamless failover during outages. Strata helps you avoid app refactoring and reduces legacy tech debt, making your identity systems more robust and efficient. Strata does it better and at a better price. Experience stress-free identity management and join industry leaders in transforming their identity architecture with Strata. Visit strata.io/cyberwire, share your identity challenge, and get a free set of AirPods Pro. Revolutionize your identity infrastructure now. Visit strata.io/cyberwire. And our thanks to Strata for being a longtime friend and supporter of this podcast.